remote access Trojans are commonly used tools in cybersecurity for both legitimate purposes and by malicious actors. So, remote access Trojans enable remote control and management of a computer system, allowing a user to perform actions on a remote machine through the network connection. So, while some remote access Trojans like TeamViewer are widely used for legitimate purposes, others are specifically designed to be stealthy and hard to detect, and making them attractive to hackers. So, remote access Trojans consist of two components: a client program that runs on the victim's machine and a server program that runs on the attacker's machine. So these components work together to establish a network connection and enable remote control. So there are two main configurations in which remote access Trojans operate, depending on who initiates the communications, which is forward connections and reverse connections. So let's get started by learning about forward connections. So in forward connection setup, the attacker initiates the connection with the victim's machine. So the attacker server program actively connects to the client program running on the victim's computer. So this configuration is useful when the attacker knows the victim's IP address or has some access to a network infrastructure that allows them to reach the victim's machine directly. And we also have the reverse connections. So in a reverse connection setup, the victim's machine creates a connection to the attacker's machine, and the client program running on the victim's computer establishes the connection with the attacker's server program. So this configuration is often preferred by attackers because it bypasses firewall restrictions and allows them to gain access to systems behind network boundaries or with dynamic addresses. So both forward and reverse connection remote access Trojans provide attackers with a range of capabilities to control the victim's computer remotely. So once the connection is established, the attacker can perform actions including but not limited to file management, like manipulating files and directories on the victim's machine, such as uploading, downloading, modifying, or deleting files, and system control, executing commands or running scripts on the victim's computer, enabling actions like launching applications, manipulating settings, or restarting the computer, surveillance, monitoring the victim's screen, capturing keystrokes, or accessing the webcam and microphone for covert surveillance, and data theft, so stealing sensitive information such as login credentials, personal documents, or financial data stored on the victim's machine, and also botnet creation, transforming the compromised machine into a part of botnet, which is a network of infected computers used for coordinated cyber attacks. So for remote access Trojan purposes, we will use socket programming in Python. So before learning about malware development, it is necessary to learn about the network programming in Python and how we can create a network application. So the first step in learning network programming is to learn about what we call sockets. Sockets here. We can also write it on the screen like that. Sockets. Oops. Sockets. Sockets here. So sockets provide a fundamental mechanism for creating network-based applications, and our malware is going to be essentially a network application, right? So let's start by understanding the sockets first. So before we jump into socket programming, let's understand what sockets is and how it can be used to develop network-based applications. So a socket is one endpoint of two-way communication link between two programs running on the network here. So this is the sockets, for example, and this is the communication, like, so it's actually, it might be sound like something more basic, but it has, it gets more complicated when we deep dive into it. So a socket is bound to port number so that the TCP layer can identify the application that data is destined to be sent to. For example, for every socket, we need some port number. So this is IP and port, right? Port. And sockets are generally used in client-server communication, where one node is a client, here, client, and the another node is server, and that's responding to that call here or connection, right? So at the each end of the connection, each process, such as network initiation program or a network responding program, will employ a socket. So a socket is typically identified by an IP address concatenated with a port number, like this. In typical scenario, a server usually listens on a certain port for incoming connection requests from clients, and once client request arrives, the server accepts the request and initiates the socket connection with the client. So servers implementing specific services here, such as HTTP or HTTPS, or like telnet, FTP, and so on. So they listen on popular, known and well-known ports such as 80, 21, and 443. And keep in mind that ports from 1 to 1024 are regarded as well-known ports and should not be used in implementing on your own programs, as they already reserved. So in some ports you might use this in some programs, but in somehow they will be used for some programs, and your connection will be failed somehow. So and let's try to understand how sockets work in Python here. Here now we will import socket. So to create a socket in Python, we utilize a socket library. So this library is a part of Python's standard package. This is a part of Python's standard package, so we don't need to install anything. So now let's take a look at the application programming interface of this module. So an API is a software interface to code base that lets you access functionality of the code with some level of abstraction. So we have this socket here, for example, socket.socket here. So this socket here, application program interface, helps us to create a socket object. So we can make use of this function called this, so to create a socket, right? So let's take a look at the parameters of this method. So to see what parameters are available in the function, we can use Control and P to see it briefly here. And as you can see here, it gets family, address family, socket kind, port, and file now here. We can also open this here with here, generate folder, go to declaration or usages here. And as you can see here, we are seeing family type proto and file now here. This is the function here, how it's written. And here you can also use the docs documents to learn more about the socket function. And here, as you can see here, we are seeing that, oops, not here. So here we are seeing a socket in a class, and its constructor requires family type proto and file no parameters. In this case, it's not actually using. And as you can see here, we have a commands here and docs. So for now, you just need to understand that calling the constructor of the socket here calls calling the constructor of the socket calls return a socket object that can be used to communicate with other devices. And we also have socket.bind here. So also let's take a deep look at this again. We'll go to implementations, and here implement a type declaration. Here we can also go to type no, we will go to declaration or usages or implementation. I'm sorry. Cannot find declaration here. So that's because cannot find the reference bind socket pair here. So create a functional model. So here, after you created this socket object here, for example, socket or my socket, and after that, after creation of the socket, we will do my socket.bind here. So this function here lets us implementations, and as you can see, this bind here. So to create a server, you need to bind a socket to the IP address and the port that the socket will utilize for communication. And also keep in mind that this function is only used when creating a server program. So for servers, these must be explicitly assigned, since the server has to listen for incoming connections on a specified port. So in the case of a client, the IP and port are automatically assigned, so you will not use this function on a client application, but you will need that in server application. And we also have the listen here, listen function. So this listen function is used by servers to listen for any incoming connection as per the configuration assigned this bind here. So my socket.bind method. So in other words, it waits for any connection attempt to the specified IP on the specified port, and this requires a queue size for the number of connections to be held in quote here. And as you can see, we are only going the backlog one integer here. So here this means allow 213 connections at a time. In most cases, you can use also. Depends on the project, actually. You can also use 1000 connections at a time or 5 connections at a time. So it depends on the project, right? And we also have the accept. So as the name indicates, this my socket accept. So socket accept here, accept connections made by clients. So this is actually a blocking function call, so which means that the program execution will pause here until the connection is successfully made. So once a connection is made, the execution program will continue. And we also have the mySocket.connect here. So as you remember from the accept, this is also block execution until the clients connect. So the question now arises, how do clients connect? So there's a connect comes into play. This method initiates a connection to the server, and if a server is waiting for incoming connections, communication will follow. So when a call to socket connect happens, socket accept gets unblocked in the server and execution of the program continues. So don't worry if this all seems very confusing to you at the moment as to which functions are called in the server and which functions in the clients, but you will get a clear idea of this when we build examples here. And we just need to also consider 3 parameters as well, which we will use in next project of ours. Then one of which the socket.send. So once the connection is made by between the server and clients, the most important part of the program comes, which is to send data over these connections. So this is where most of the user-defined logic will reside here. So the socket send method is used to send bytes over the network. So and keep in mind that the input to this function is bytes. So any data, as you can see, it's bytes, right? So any data you want to send over this connection should be in the form of bytes. So, which is not a hard thing to convert from bytes to strings or from files to bytes. So it's actually easy, not like sounds like you might confuse it from first, but and like I will be honest, because like 5 or 6 years ago when I started working on these sockets, like damn, how we will send and receive bytes over the network, but we can't read the bytes. But don't worry about it, because Python has libraries and functions to turn bytes onto like meaningful messages or meaningful messages to bytes, so don't worry about it. And we also have this socket, my socket. Of course, we have this send, and we will also need to have receive. So this method, as the name suggests, is used to receive bytes once the user sends the data. So also keep in mind that every call to the send or receive methods should be handled properly. For example, if the server is sending data, the client should be ready to receive this data and vice versa. So the input to this method is the number of bytes you want to receive at once here, and bytes here. So this is the buffer. This is the buffer created by the program to temporarily store data, and once a certain memory of bytes arrive, they can be read, and the buffer is ready for the next cycle. And lastly, I know this lecture actually might be quite long for now, but this is the last method here that we're gonna use here, which is the close. So once you have done everything you wanted to do with a program, you must close the socket so that the port can become available to other programs to be used. So also keep in mind that even if you don't close the socket properly, it will be released by your operating system after a period of time once your program exists or computer restarts. So however, it is always a good idea to close the sockets manually inside the program. So if the program exists and the socket is not closed properly, any incoming request may be blocked, or the operating system may refuse to use the socket for the next program because it may think that the port is still in use. Hello, my name is Tayfun, and in this lecture we will write a program for the attacker server or the pentester server that our pentesters will use that server here, that program. As you learned in previous lecture, we need two programs for the remote access Trojan for the server and client side. So now let's go to our Kali machine environment, and as we've done, we will not require any external libraries in this lecture, but it's always a good idea to use virtual environments to keep track of the dependencies on our program. Also, you will also now create a new file, or actually let's create new file named, actually we can also delete this main.python file and delete this from here. We will also do it here, and now we're gonna right click on the project folder and click on the Python file, new Python file, and now we're gonna write since we're gonna create the server side of the application in this lecture, we will write server rat, and that's it. And here let's actually check our IP address of the Kali machine. So if config, and as you can see, this is the IP address of our Kali machine. And for the victim's IP address, we're gonna check. Actually, let me check if this Windows is opened here. It's opened. Let me actually show it to you. This is the Windows here. It's opened and active. So for now, we will just gonna hide it. Now we'll go back to Kali Linux, and here what we're gonna do is we're gonna get the IP address of Windows machine without even touching it. So now we're gonna use the nmap to define what device in our local network uses the operating system. In order to do that, we will enter first the 192.168.13 and 1. After that, we will add 24 to just scan 255 IP addresses and press enter. And keep in mind that this is not 0 or lowercase o, this is uppercase O here as a parameter. And as you can see here, TCP/IP fingerprinting for operating system scanner requires root privileges, and now we will use the sudo to run it. So Kali, and also we will open the notepad here, now, or I think it was a mousepad, yes, and here we will write the Kali or attacker, or actually pentester is more appropriate term for this example. And here we will write 192.168.13, and here we have the 13 point, I think it was 138. And after that we also, let's actually also add the operating system, which is Kali Linux 2023. And also after that we will add the target machine, target here, and target here we will, after this nmap scan, let's go back to it. And here, as you can see, we are seeing all the devices in our network. Here this is VMware, and we have this IP address here, and as you can see here we have the nmap scan for 139, and we have, this is the router of our local network, and here this is our Windows machine. And as you can see here, it might say Microsoft Windows XP, that's the old version of it, but here, as you can see here, it's written 2019, or might be this Windows Server 2019. So actually this is just a guess. So nmap, as you can see, it's also written the just guessing here. So we know that this target machine runs on Windows, probably Windows 10, and as you can see here, Microsoft Windows Server 2019 and Windows Microsoft Server 2019 is actually Windows 10. We can check it out from here. MS Server Windows or 2019 here, and we will check how it looks like. It's yes, I think it's Windows 10. Based on Windows 10, but it was the server version of it. So we know that it is Windows 10, and now we will also add the IP address of our attack target machine, 192.168.13 and 139, and that's it. And here Windows 10 here. And after that, what we're gonna do is we're gonna go back to PyCharm here. We'll close that, because actually it's going to be good to put some space on the left side of the screen here. Now the IP address of our Kali machine is this, and for the victims or targets Windows machine is this. So next we need to select which port we will be listening on for incoming connections. So as you learned in previous lectures, we need ports, right? So we need to select ports. So you can select any port above 1024, or you can select any port. We will add this here as a comment, any port on or any port above 1024 and less than 65,300, 300. Actually, let's actually check the maximum number of ports here. Maximum number of ports, maximum max number of ports in TCP/IP, and here we will get the answer of 65,535, right? 65,535. And here, let's actually, we will use the port number 9877, and yeah, you can also choose whenever you port, whenever you like, or whatever number you like here. But in most conditions, you need to choose the most suspicious, less suspicious port number. For example, 1337 is mostly used for, or 1339 is mostly used for remote access Trojan programs. So you can also choose some 8080 to make it less suspicious. But you can choose, as I said, you can select any port above 1024 and less than 65,535. And now we're gonna write our program. So as I said, we will use we will use 8788. So we will firstly import the socket here, and after that we will create the socket object here. So actually we will also need to use the if name to run our program here, and after that we will use the main. So here actually you learned in previous lecture where we are reading this, and after that we're gonna use the hacker server socket here, and after that socket that, remember, you learned almost all of the methods that we're gonna use in previous lectures. I think it was a 18-minute lecture, so it was a pretty long. So socket. So first we're gonna socket AF inet. So this is the IP address here. Socket inet. So you will know why are we writing this inet here. And after that we will also input as a parameter of socket kind, in this case socket.sock stream here stream. That's it. And here on the first line we are simply importing the socket model from the Python standard library STL, and next we are creating a socket object. So the two parameters, socket.af inet and socket sockstream. So let's see what they mean, right? What they mean. So remember that we talk about the IP version 4 and IP version 6, right? You remember that? And so this is exactly what the socket AF inet and socket sockstream means. So if you want to use IPv6, which you probably won't, you will, in that case, you will use inet6 here, and as you can see, inet and inet6. So inet6 is IP version 6 and inet is just a regular IP version 4. So remember that this here, actually let's run if config here, I will show you again, and as you can see, this is our IP version 6 address of our local here, and this is the IP version 4 address. So we're gonna use IP version 4, and here next here we need to define what protocol layer we wanna use. So here we have options for either TCP or UDP socket. So in our examples, we want to use reliable connection. So we will use TCP. And so sock stream means that we are creating a TCP socket here. So if you want to create a UDP socket, you can also, which again you probably won't for the most part, you can use the socket.sock stream. Here, as you can see, we have sock diagram and sock stream. So we're gonna use sock here, sock stream here. But if you wanna use the UDP, you can select that sock diagram. So we will use sock stream here. Sorry, sock stream. Perfect. So this is the TCP and IPv4 TCP here. And next, we will bind this server to the Callis IP address on. Let's remember the port. So here, port here. So port. So we will bind this to Callis IP address, as I said, attacker IP, and we're gonna enter the attacker IP here. And as you can see here, we enter the attacker IP in the strings, of course. And after that, we will enter the port. So of course, we will not use the different ports for attacker and server side. So we will just use the one port for each side. So think of ports like doors here, like doors in hotel, right? You need to use same doors to meet some person on hotel, right? So that is how the ports work on the TCP/IP model. And also we will use the socket address. So my socket address here, we will pass two arguments, IP and port. Attacker IP and attacker. Actually, sorry for that. We have, as you can see, we have hacker server socket here. And now what we're gonna do is we will create the two here, my socket address. It's gonna attacker IP and attacker port. So attacker port. So as I said, sorry for this, attacker port. There's no attacker port and no victim port. There is a same port, so they are using same port but different IPs here. So this is how internet works. So also keep in mind that you have to give the IP address and port here in tuple. So this is, we created tuple here to the socket bind here. So you need tuple, as I said. And here we will enter the hacker server socket, the bind. We will bind this my socket to here. And what we're gonna do is here we'll pass this my socket address. And after that, we need to listen for incoming connections on the specified socket with the help of this command, which is hacker socket.listen. And 5, as you remember, this is the second here. So now that our program configuration is almost complete, we can start listening for incoming connection requests, which we will do in next lecture. So I'm waiting you in next lecture here. Hello, my name is Stefan, and in this lecture we will be creating a simple server application using Python sockets, and I will guide you through the code step by step and explaining each line and function along the way. So by the end of this lecture, you will have a clear understanding of how to create a basic server using Python. So let's start by writing the server application here. So as I remember, in previous lecture we did this here. So we added first we created set the attacker's IP addresses and the port numbers to the list. And actually this is the kind of the IP address that we've been waiting the request or response from. So we will changing to 0.0.0, and because in this case, for example, we have this amount of computers in the network and they all have the specific IP addresses. So these are the computers and this is the attacker computer here. And here, by typing the specific IP address, this means that we are waiting the response from specific IP address here, specific computer, and actually that's not a good solution for remote access trojans in most cases, because we will want clients from every IP addresses, and that's why we're gonna write 0.0.0 to wait all the clients from every IP addresses here. And after that we will have the port here and IP to listen here, and we will change also here IP to listen. That's it. And after that here, remember we create a socket object for the server here. Oh, sorry, we create a socket object for the server. And after that, here we, as you can see here, my socket address IP to listen port. So this is a tuple. We will define the server address and IP here, and after that we bind the socket, in this case my socket address variable, to the server address. Yes, you remember we have used the socket AF inet, which is IP version 4, and TCP here, we use TCP protocol. And after that here we listen for incoming connections, and we here allowed 5 queued connections here. And after that let's actually use the print here to show the user. In this case, the only user that the server is gonna run on it, it's gonna be V. And so this is the server is actually the attacker application, and here we will print here, so listening for all incoming client connection here. And here I want to mention that we are printing message for like listening for all the, we are notifying the user that we are listening for all the client connections here. And after that we will accept a client connection. So in order to do that, we will use client socket. In this case, it's going to be client socket, and we will also add a client address here, and we will make it equal to server socket here. In this case, our server socket is hacker server socket that accept here. That's it. And here we will print the client's address to confirm the connection. And in order to do that, we will print here, and we will print that we are connected to client here, and we will print the client address. So you can also do this with formatting here. In order to do that, we will use this, and here we will just add F here before the quotes here, double quotes. And after that, we will receive the print message from the client. So we will, so the client will send us some message here, and we will receive and print that message to the user. And here, while we will work this loop will run until we press the Ctrl+C or terminate the program somehow. We will create a new value here, which is data. So client socket that receive here, and we will write 1024, and we will also decode that. So here, data here. So here we will receive the data from the client. In this case, we have a condition that we wanna receive that data up to 1024 bytes and decode it from bytes to string. So remember, in previous lectures I explained that if you want to send some message over the network, you need to first turn it to bytes, and when you're receiving it, you need to turn it bytes to string, right? And here we will also add if condition here. So if no data is received, it means that the client has closed the connection. So we break out of the loop here. So if not data, we will just break here. That's it. And after that, we will, after breaking the loop here, we will print the received message, or just write a message from client here. And after that, we will enter the data. So we're gonna use the here data. That's it. And we will also use format. Perfect. And after that, of course, we need to, after using the socket, we need to close the socket. We will use client socket dot close here. And after that, we will server socket server here, socket server, or I think we have the client socket, client address, and we have hacker server socket dot close as well. And this is a client socket, and this is the server socket here. And now we're gonna run this program here to say everything is okay. And as you can see here, we are waiting for the response here. And now we're gonna run this program on terminal. Sudo python 3. We might get an error because we are running the program twice on the same port, but we are still listening here, and we will test that out here. Server rat. And as you can see here, address is already in use, and we will stop this here. And here, as you can see, Vascience, they're closing this as well. And here, and as you can see here, we are listening from the terminal here. Actually, they're quite the same thing here in this case, but here, as you can see here, we are listening from terminal. So I'm waiting you in next lecture for developing the client application. So this was the server side. So here in previous lecture, we completed our programming, but if you didn't understand it, the line of codes, and here I will explain these codes line by line. So if your program worked and you understand everything we wrote here in the previous lecture, then you might skip this video and continue on the next lecture, which we're going to develop a client side of our remote access Trojan application. So let's get started. So now in first line, we're going to import the socket module, which provides the necessary functions and constants for creating sockets. And in line 3 here, the if name equals main condition ensures that the following code is only executed when the script is run directly, not when imported as a module here. So, and here we have we are setting the attacker's IP, and as I explained in previous lectures, so we're gonna get the connection not a specific user, but from all the users on the network. And here we are setting the port number to listen on, and here we are creating a TCP socket object for the server using the socket here, socket method, and socket AF-init specifies the address family of IP version 4, and the socket sockstream indicates that this is a TCP socket. So, and after that, we are combining the attacker's IP address here, IP address and the port number to form the server address as a tuple, because server address accepts this as a tuple. So remember, tuples are like lists or dictionaries, so they are the variable types. So this is a primitive type actually, so this is not from the socket module here. And here, after that, we bind the server socket to the server using bind. And after that, we start listening for incoming connections, and the argument 5 here specifies the maximum number of queued connections. And in line 14, we are printing listening for all incoming client connections. So here we will printing the message indicating that the server is listening for client connections. So when we run this code, and as you can see here, we see this message and our program is still waiting. And after that, here this, so this accept, we now accepting a client connection using accept method blocks until a client connects and returns a new socket object representing the client connection along with the client's address. So, and after that, we are printing the address to confirm the successful connection here. And here, we will enter a loop to receive and print messages from the client. So here we are receive data from the client using a receive method, and the argument 1024 specifies the maximum number of bytes to receive at a time. Here decode the received bytes into the string using this decode method, and we have an if statement here. So if no data is received, which is, for example, an empty string, it means that the client has closed the connection and we break out of the loop. And here we are printing the message from the client, and we are also here closing the client socket and server socket. And to summarize, what we have created a server application that listens for incoming client connections, accepts a connection, and prints any messages received from the client. So we have gone through the code steps by step, explaining each line and function along the way. In next video, we will create a client application that can connect to the server and send messages. So stay tuned for that. So I hope you find this lecture helpful in understanding how to create a basic server application using Python sockets. And in next lecture, we will create a client application to combine with a server and build a complete client-server system. So thank you for watching and see you in next lecture. Hello everyone, my name is Tayfun, and in this lecture, we will be continuing from our previous lectures on creating a client-server system using Python sockets. So in this lecture, we will dive deeper into the client application code, explaining each line and functions in detail. And by the end of this video, you will have true understanding of how the client applications work in Python. So here, let's begin by reviewing the client application code here. So first, we will write it, and here, in order to create a new Python file in PyCharm, or actually you can use these tricks in other, for example, Visual Studio Code as well. You will click on the right click on the project folder here, and here you come to new and select the Python file from it, and we will name it client rat here. So we will make this rat here so from the a simple messaging application. However, in next lectures, we will execute commands, get a screenshot, get a keylogger. So we will do that. But for now, we will do a simple messaging protocol with using TCP, and after that, we will widen our program to do that. And here we will firstly import the socket, as well as I always do, I will explain all of the codes line by line, and you will have a best understanding of how these codes work and what these codes mean. So it's actually easy to write codes, but it's actually more harder to understand what these codes mean. So here we will name here and here main as well, two equal to signs main, and after that we will firstly set the target server's IP address and the port number to connect to it. In this case, our target is going to be our Linux machine, Kali Linux, because this is a client route, right? So what we're going to do is we will firstly check the if config here to see what is our IP address, and as you can see here, it ends with 138. And in order to do that, we will use the server IP here and 192.168.13.138. So 168.13.138. That's it. And we will also use the port here. So we have to use the same port as we use in server side. It's this here. So we will use server port as well, and that's it. A3. Oops. Actually, server port in server port we have to write in integers. I think it was a 87 and 88. Yes. And after that, we'll combine the target IP address and the port number to form the target address as a tuple, because the client socket, so our socket here, accepts tuple only. And after that, we will target address here, and after that we will first enter the server IP and after that server port. And after entering this, we have to create a socket object for the client, and in order to do that, we will use the client socket here, socket, and we will use the socket method, and here, as we did in previously, we will use so remember, this is a server and this is a client here, so we will use the socket IP version 4 and TCP here, TCP protocol, and here we will use as well here socket, so here, and after that we will also use this TCP. So if we use the UDP on the client side and the TCP on the server side, our program of course will not work because they don't share the same language, same protocols with each other. And here we will also use a sock stream. That's it. And after that, we have to connect to the target server. In order to do that, we will use the client socket dot connect, and after that we will get the target address, because and as you remember, this is a tuple which holds the server IP as a zero index and the server port as a first. And here we will enter the target address as well, and that's it. So after that we will need to print a message indicating that the client has connected to the server. So now we will print that the client is connected to server IP. We will also write a server IP to inform the client. Actually, this is a remote access Trojan, so we will not inform it, but for us we will write some here. Client is connected to, I think we can write it for learning purposes here, but in reality, of course, you will not write your client is connected to something or the IP addresses here. Remote access Trojans or remote access tools has to be stealthy, right? So now we will use the server IP, and after that we will also use the server port. That's it. And here, after that, of course, we need to use a double dot here, so make it look more presentable. And after that, we need to get user input for the message to send to the server. In order to do that, we will use the message input here. We will get input from the user, and here we will enter your message, or is that your here? Enter message. We are just a program writing here, right? We don't have to get personal. Enter your message, of course, here, and we need to send the user input message to the server embedded as bytes. So as you learned in previous lectures, we need to send our messages in bytes. So as I told you, we firstly need to convert our string to bytes on the client side, and in order to receive that text message on the server side, we need to turn that byte to readable string here, right? So now we will use the, so after that we get the message from the user. Actually, let's run this and see what happens. So as you can see, connection refused because there's a no here. Actually, we can firstly 138 because connection refused because we are not open the server here, server side of the rat. So we will now open cd pycharm, and again we will go to the here, and now we will python 3 server rat here. That's it. And as you can see here, it brought us a listening for all incoming client connection, and whenever we run it, and as you can see here, address is already in use. Oops, because we are running in the server here, so we need to run the client here. And as you can see here, we need to enter the message, but here, as you can see here, we entered the message and process finished here, so our program is executed, completed the execution, and we didn't receive any, but we connected to the client here, right? But now what we're gonna see is, you will see how to get a response and turn this message here, this input, into the byte here. And in order to do that, we will use the client socket.send. We will send this and encode this. So message.encode. We will not give any variables inside this parameter because we don't need to. So we will send the user input message to the server, and we will encode as bytes. And after that, we will have to receive a response from the server, right? So response here, and we will client socket dot receive 1024. Actually, in this example, in server side, we haven't programmed it yet, but as I said, we will like make this application more and more bigger and bigger. We will add functionalities to this remote access trojans and so on, so it will be so much better here. So now we will decode it here if we have any messages, but in this case, in our server side, we haven't coded this messages to send something here, as I remember. Yes, as you can see, we are not sending any message to the client side, right? And here, after decoding it, we will need to print a service response. For now, as I said, we didn't program it on the server side, but it wasn't hard to write this here, but it will not affect any of our functionality. This code will just stay here, and if there's any response, it will print to the here. And print here, we will use the server response is and here we will also add response. So as you remember, I always use formats for writing things like that, mixing variables with printable strings here, and we will enter the response here. And after that, we need to close the client. So client socket dot close. And here we completed our program. Let's firstly run it, but here I have a much bigger surprise for you. So we will run it on the Windows 11 machine to see what happens. So now I will run the CMD on my host machine here. And here right now, I will copy the client side here. So as the tradition, our server side is going to be the Kali machine because it's an attacker, and our target side is going to be Windows machine. So now I will copy this and run it on Windows 11 actually. Hello, my name is Stefan, and in this lecture we will firstly explain the codes we wrote here in the client side. In previous lectures we explained the server side here and what this code means and what their function is, and here We will explain these codes one by one. So here we are importing the socket model, which provides the necessary functions and constants for creating sockets. And here with this, as you remember from previous lectures, this condition ensures that the codes is only executed when the script is run directly and not when imported as a model. And here we are defining the target server IP and server port here, and here we are combining the target IP address and the port number to form the target address as a tuple. And here we are creating the TCP socket for the client using socket here, and here we are using AF-INET, which specifies the address family IP version 4, and here we are specifying that indicates that this is a TCP socket here. And here we are connecting to the target server using this connect method, and we are passing the tuple here as a server IP and the server port. And after that, we are printing the message that indicating the client is connected to the server IP and server port, and here we are entering message. So we are getting the user input for the message to send to the server using this input method here, input function, and the user's input is stored in this message variable. And we are now send the user input message to the server using this send method, and the message is encoded as byte here for sending here. As you remember, we need to send the messages over networks as a byte format here, and then we will need to turn that to string here when receiving that. And here we are receiving a response from the server using receive here, and the argument 1024 specifies the maximum number of bytes to receive at a time. And after that, we are printing the server response, and we are closing the client. So here, let's take a closer look at the key concepts and functions used in this client application. So the first phase is socket creations. So we create a socket object for the client using the socket f-init and socket stream. So as you remember, socket init specifies the address family of IP version 4, and socket stream indicates the TCP. And in the phase 2, we are connection establishment. So we are doing a connection establishment. So we connect to the target server using the connect function and pass a target address as an argument, and this establishes a TCP connection between the client and the server. And after that, we are sending a message here. So we use the send function to send the user's input message to the server, and the message is encoded as bytes using the encode method, and this ensures that the message is sent in a format that can be understood by the server. And after that, we are receiving the message. So we receive the response from the server using this receive function here, and the argument 1024, as I said, specifies the maximum number of bytes to receive at a time. So this is actually ideal for our messaging application, but you can do more, for example 2048 or like more here, depending on your needs and projects here. And at the end, we are closing the connection. So after receiving the server's response, we close the client socket using the close method. So this releases the resources and terminates the connection between the client and server. So here in this lecture, you understood how it established a connection to the server, sends a message, receives a response, and closes the connections. And we also discussed the key concepts and functions used in the client application. Now what we're gonna do is as you can see here, we have this Windows CMD screen here. This is a different computer. This is my computer here. Now what we're gonna do is we're gonna go to the terminal here and run this application. So here, let's first check our IP here, and as you can see, it's 138. Now what we're gonna do is we will go to the project folder here, in this case PyCharm projects ls, and we will go to project name. So clear here, and we have client rat, client server. So I have copied the exactly client rat to the my Windows machine, Windows 11 machine, and now we will run the server rat, and then we will run it from the client side here. And what we're gonna do is Python 3 or Python 3 here, server rat here, and as you can see here, it wrote us that listening for all incoming connections. Now what we're gonna do is let me actually open the Windows on the second screen here, and on that side. So perfect. Now what we're gonna do is we will write the, let's actually read the inside of the program, with the cat here. Of course we need to go to Python 3 hacker tools. I copied this program to Python 3 hacker tools here, so actually let's make it bigger, and here click enter, and here we will have this client rat.python file. As you can see, it's the program size is actually so small, 557 bytes. So now let's actually read this inside files with cat here, and as you can see here, oops, cat. So cat is not recognized as internal or external command. So here, of course, the cat is for Linux here, so we will write the type here and client rat. And as you can see here, we are seeing this, the input of the client rat application. So we can go to PyCharm here, and you will see the same. And as you can see here, port is same. This is the server IP. This means that we need to provide it of our Kali machine IP address, and everything goes like okay. And now we can run the program. So Python, and we will write the client rat py. So here Python is recognized as an internal or external command or offerable. Yeah, of course we need to write it. So here I written a typo here, Python client, and as you can see here, we connected to the Kali machine, so we can send the messages here, passwords here, and as you can see here, we received on the attacker side. We can write another things as well, and so on. So this is how our programs work. In next lectures, we will be widening our program functions. We will make, for example, keyloggers, like screenshot makers, and so on. So I'm waiting you in next lecture.